Students, in chapter number 15, which was about organic compounds, you have mostly studied about hydrocarbons. In this chapter, our main focus is going to be hydrocarbons, and we are going to study the classification of hydrocarbons. After today's lecture, students, you will be able to understand alkanes, its nomenclature. Nomenclature means the rules on the basis of which we name the chemical compounds, and we are going to use International Union of Pure and Applied Chemistry rules for naming alkanes. First of all, let us look into the definition of hydrocarbons. Organic compounds which contain carbon and hydrogen only are called hydrocarbons. The ability of carbon atom to attach with each other to form a chain or ring is called catenation. And this property of carbon to form long chains is responsible for the wide variety of hydrocarbons present in nature. Here are a few examples of hydrocarbons. The first one is propane. As you can see, it contains 3 carbon atoms and 8 hydrogen atoms. The second one is benzene. The third is cyclohexane, and both these structures contain carbon and hydrogen only. Therefore, they are called hydrocarbons. As there is a wide variety of hydrocarbons, there must be classification of these hydrocarbons to make the studies more easier. Here's the classification of hydrocarbons, which are divided into various classes on the basis of their structures. So the hydrocarbons are first of all classified as open chain or acyclic hydrocarbons and closed chain or cyclic hydrocarbons. Acyclic means without having a cyclic structure. The open chain hydrocarbons are further subdivided as saturated hydrocarbons and unsaturated hydrocarbons. The unsaturated hydrocarbons are further classified into alkenes and alkynes. Closed chain or cyclic hydrocarbons are classified as alicyclic and aromatic hydrocarbons. Now students, we are going to study the details of all these classifications today. The first classification of hydrocarbons are open chain, which are also called as acyclic hydrocarbons. They are defined as hydrocarbons in which carbon atoms attached with each other to form open chains. That is why they are called open chain hydrocarbons. They are classified into saturated hydrocarbons, which are called as alkanes or paraffins, and unsaturated hydrocarbons, which are called alkenes or olefins, and alkynes or acetylenes. Here's an example of alkanes. In alkanes, you will see all single sigma bonds, whether it is a straight structure or a branch structure. And in unsaturated hydrocarbons, you may notice the double bonds or triple bonds might also be present. Now let us look into the detail of these two. Saturated hydrocarbons, which are also called as alkanes or paraffins. Now why are they called paraffins? Because they are having a little or no affinity for the chemical reaction. Why is it so? Because of the following features. All the carbon atoms are attached by a single bond or a sigma bond. Each carbon atom is sp3 hybridized. They might have a straight chain structure or a branch chain structure. For example, in N-pentane, you will see a straight chain structure and isopentane having a branch structure. As you can see, each carbon atom is making 4 bonds. It is saturated. No further atom can be added to the carbon atom. Since no further atoms can make a bond to the carbon atom, that is why they are called saturated hydrocarbons. The second classification of open chain or acyclic hydrocarbons are unsaturated hydrocarbons. These are the hydrocarbons in which at least 2 carbon atoms are attached through a double bond or a triple bond. If a double bond is present between the 2 carbon atoms, they are called alkenes, and each carbon atom making a double bond is sp2 hybridized, whereas in alkynes making a triple bond, each carbon atom making a triple bond is going to be sp hybridized. The second major classification of hydrocarbons are closed-chain hydrocarbons. These are the hydrocarbons in which carbon atoms are attached with each other to form a ring. Closed-chain hydrocarbons or cyclic hydrocarbons are further classified as alicyclic hydrocarbons, which are called non-benzenoid cyclic hydrocarbons or alicyclic hydrocarbons. The second classification is aromatic hydrocarbons, which contains a benzene ring. They are called aromatic hydrocarbons because they have characteristic fragrance. Now let us look into the detail of these two classifications. Alicyclic or non-benzonide hydrocarbons possess two hydrogen atoms less than the corresponding open chain hydrocarbons. For example, we studied about propane, which have 3 carbon atoms and 8 hydrogen atoms. When this propane makes a cyclic structure, you can see it contains 3 carbon atoms but 2 less hydrogen atoms. As you can count them, there are 6 hydrogen atoms. Similarly, all these alicyclic hydrocarbons are having 2 hydrogen atoms less than their corresponding open chain structures. The second classification of cyclic hydrocarbons are aromatic hydrocarbons. Benzenoid hydrocarbons are called aromatic hydrocarbons. Benzenoid means benzene containing structures. You will see that all the carbon atoms are sp2 hybridized since they contain double bond. Benzene is the simplest aromatic hydrocarbon having hexagonal structure with alternating single and double bonds. Other examples of aromatic hydrocarbons are naphthalene, in which 2 benzene rings are fused together, and anthracene, in which 3 benzene rings are fused together. These are the example of aromatic or benzenoid hydrocarbons. Students, now it's time for you to think. Why unsaturated hydrocarbons are called olefins? Think over it. You have 1 second. Unsaturated hydrocarbons are called olefins because they have oil-like consistency. Students, before starting IUPAC rules for naming alkanes, let us see what is the definition of alkanes. They are simplest organic molecules with only carbon and hydrogen atoms, commercially important as fuels and oils. For example, pentane and isopentane, these are the example of simple alkanes. Students, now let us start the IUPAC rules for naming alkanes. These are very important rules, so please pay attention. The first rule says, locate the largest continuous chain of carbon atoms independent of the direction of the chain. Now, whenever you are going to look at a molecule, it might be branched. So, independent of direction, you have to select the longest continuous chain, and that chain will be called as the main chain, stem chain, principal chain, or the parent chain. Now let us learn this rule through an example. In this molecule you can see, if I will start numbering, I will get a carbon chain comprising of 5 carbon atoms. But if I would have proceed upwards after carbon number 3, I would get a chain comprising of 4 carbon atoms. So that will not be my chain. I will select the chain with largest number of carbon atoms, which in this case is pentane. Another example, as you can see in this example, if I will start numbering 1, 2 and 3 and continue further in the straight direction, I will get a chain of 4 carbon atoms. But instead, if I will move downwards to this carbon atom, I will get a chain carrying 6 carbon atoms, and my principal chain will be a chain of 6 carbon atoms, which will be called as my principal chain. Students, the second rule says that if there are 2 or more chains of equal lengths, the chain with a larger number of branches is selected as the main chain. For example, look at this molecule. It is a highly branched molecule, so you may get more than one long chain. For example, if we start numbering from this side, you will get a chain of 6 carbon atoms. But if you view this molecule from another side, you will again get a 6-member chain over here. So as the rule says that we have to select the parent chain with larger number of branches. To understand it, let us see this molecule again. If we select this as our parent chain, then you will get a branch from this carbon atom, and this whole substituent will be considered as a single branch. Whereas if we consider this as our main chain, then you will see that there are 3 branches for this main chain. 1, 2, and 3. So we will select this as our parent chain instead of this molecule, which will give a single branch. So this is incorrect. The third rule says that number the main chain starting from the end nearest to the substituent. Let us understand this rule through an example. Look at this molecule. We can number it from either sides. If I start numbering from the bottom, I will get my first substituent at carbon number 4. But if I start numbering it from the top, I will get these 2 substituents at carbon number 2. So as the rule says that we have to start numbering from the end which is nearest to the substituent, so carbon number 2 is more nearest as compared to carbon number 4. Now students, here is time for you to think. What if the substituent appears at equal distance from either side? Means that if you are going to start numbering from any end and you are getting the substituent at equal position, then what to do? I hope you have understood today's lecture and able to solve this assignment. Thank you and Allah Hafiz.